Welcome all to the Phase 2 overview webinar Q&A for NASA's Break the Ice Lunar Challenge. Thank you for joining us to learn about Phase 2 of this important competition. I'm going to be kicking things off, and then I'll be passing the presentation over to some of our colleagues who will continue to go into depth about this next phase of the competition. So for today's agenda, we will do some welcome introductions. I'll go over a few housekeeping items in terms of the webinar and the Q&A. We'll introduce the NASA Centennial Challenges program at large. Then we'll dive into Break the Ice Lunar Challenge, giving a recap of the Phase 1, where we were, and then looking ahead to Phase 2, to understand where we are going with this competition. And then we'll close things out. I'll give a quick demo of our Break the Ice Lunar Challenge website, and just kind of give you an overview on the registration process and then also the submission process for level 1. And then we will close that out with a Q&A. So we are led by Denise Morris, who's the acting program manager at NASA Centennial Challenges. And the team for the NASA Break the Ice has esteemed experts, including Kurt and Pete, who help our subject matter experts in the field of in situ resource utilization and mining. Chris, who is a challenge consultant who will be helping lead this webinar, myself, an operations and design challenge manager, and then Mark, Harry, and Jerry are also joining us, who can provide subject matter expertise. And then we are also led by Naveen, who is a challenge manager. So on today's call, panelists will be able to speak and screen share. Although I will be driving forward mostly with the content of the presentation. Attendees will be unable to speak, but we welcome your questions. So your questions can be submitted through the Q&A feature in the participant taskbar. You've probably used this in past Zooms, but we welcome your questions. We will try to get to all of them, but if there's a lot of questions, we just won't be able to answer all of them. So we will follow up with an updated FAQ page on our Break the Ice Lunar Challenge website. And we will be answering questions on a first come, first serve basis. So the first question asked, we will work our way down the list. I ask that you give us some grace, as it takes a little while to work through the questions, so we might not be immediately able to answer everything. But the things that are said on this, the answers might lack precedent compared to the challenge rules document. The challenge rules document is the most important official document for this challenge. So the contents on this presentation should not be used beyond some guidance. The challenge rules document really is the most important place for you to read and get a good understanding of what Phase 2 challenge entails. We will be sharing the slides of this presentation, and we will also be sharing a recording of this webinar on our website, on our resources and media page. So I'll pass it over to Chris.
Hello all. So I'm Chris Ranjone. I work with the Centennial Challenges team. So I'm going to give you a little bit of a background on Centennial Challenges. Next slide, please. So we are NASA's first prize program. We are part of a broader prize program at NASA, and we put on large-scale challenges to support NASA's needs. Next slide. As I mentioned, we're part of a larger group, and together we leverage all of the open innovation tools available to us and techniques available to us to deliver value to NASA, to other government agencies, and we believe humanity as a whole. Next slide. We currently have 4 active prizes worth over $15 million, and 3 of these are focused on our return to the moon. watts on the moon, which is about powering lunar settlements and work on the moon, break the ice, which is what we're talking about today, and then deep space food, which is about feeding crew on long-term missions. Next slide.
Is there supposed to be audio with this video?
Let's try this.
Our moon,
You hear the audio?
the next
Yes.
step in human exploration beyond our Earth. In order to live there sustainably, we'll need habitats, water, fuel, and so much more. But we can't bring everything with us when we go. We need a way to collect valuable resources already available on the moon. The moon's regolith, or soil, can be used to construct habitats. Water hidden under the surface can be harvested for human use and for future propellant needs. But responsibly gathering these resources far away from our home planet will require technologies that aren't currently available. And with frigid temperatures, low gravity, and challenging shipping conditions, traditional Earth-based excavation technologies aren't going to cut it. That's where you come in. NASA's Break the Ice Lunar Challenge is looking to industry, students, small businesses, and garage inventors to develop innovative ways to excavate the moon's icy regolith and deliver water in extreme lunar conditions. These technologies and resources will be critical as we learn to live off-world. And your ideas could help us get there, extending sustainable human exploration to the moon, Mars, and beyond.
So we want you, hopefully you're all here today because you want to participate. And so what we're hoping to do today is really give you the information you need and the confidence you need to know that you can actually participate, make a huge difference, and frankly, win this thing. Next slide. So overall, this is a two-phase competition. We're currently in phase two. Phase one was where we asked people to develop a system architecture for excavation of icy regolith. It was really a design competition, everything on paper, and we awarded $500,000. Phase two is where we are today. It launched a little while ago, I think early June. And this is about now building and testing those solutions that people either came up with in phase one or that they're coming up with right now, real time. Next slide. So where have we been? Next slide. As I mentioned, phase one was about thinking big and coming up with a design for excavation of icy regolith and delivery of water to a storage facility. The challenge ran for 9 months, and we had 31 eligible submissions from 4 countries and 17 US states. We awarded $500,000, broken down as you see here. Next slide. This just gives a pictorial overview of our submissions. You could just take a brief look here. And if you go to the next slide, this is a list of our winners, many of whom are actually on this webinar today, and that we're hoping and expecting to participate in phase two. So congratulations to these winners again. Next slide. So where are we now? That's what we're here to talk about today. Next slide. So this is about building and testing. So taking those ideas that were developed in phase one or new ideas that people are coming up with today. I will say this multiple times. You did not have to participate in phase one to participate in phase two. And what we're trying to do here is have you design, build, and test or demonstrate these systems, these excavation transportation systems that meet the requirements and the rules. I'm going to go back to what Ali said. Everything we say here is a brief overview. Always go back to that rules document to make sure that everything you're doing is correct. Phase 2 is open to any team that meets the eligibility criteria. We'll go into that in a later slide. Again, participation in phase 1 is not a requirement to participate in phase 2. There's 3 levels in phase 2, with finalists demonstrating at a facility, head-to-head at a facility created by NASA. And in this phase, we have $3 million in total prizes broken up across the levels and across finalists. And there will be an opportunity for some limited number to actually test in a TVAC facility. Next slide. So here's our 3 phases. Excuse me. Phase 1, these are our 3 levels. Level 1 is detailed engineering designs and test plans. Everybody that submits in level 1 and is approved will move on to level 2. Doesn't matter how many, but everybody will move on to level 2 as long as they meet all the requirements. Level 2 is to build and test your prototype at a facility of your choosing. These are long duration tests, and the top 15 or up to 15 teams will move forward to level 3. And then level 3 is where you will bring your prototype to that NASA facility, and they'll be tested in simulated lunar surface and gravity conditions. Teams here will win cash prizes. And as I mentioned earlier, a limited number will also be provided the opportunity to test in a TVAC facility. Next slide. This is the timeline. As I mentioned, it opened in early June. We have a series of webinars to help you all learn more and support you all. And then there's some deadlines. I'm not going to go into this in detail because you will have these slides. These are also right in the rules document. Next slide. So how do you register and how are you eligible? You must register to participate. So you could go to the challenge website. Ali's going to walk you through that in a little bit. And as I mentioned 2 or 3 times already, and we're going to keep mentioning because we want everybody on here to participate, you didn't have to participate in phase 1 to participate in this phase. Then that gets us to who's eligible. As an individual, you must be a US citizen or a permanent resident of the United States, and you must be 18 years of age or older. We cannot have any minors participate in our challenges. As an organization, you must be an entity incorporated and maintaining a place of business in the United States. And then teams must be comprised of either eligible individuals or eligible organizations, those top 2 bullets there. Team leaders must be US citizens or permanent residents. Now, that doesn't mean that international individuals or teams cannot compete. They absolutely can, but they are not eligible to win cash prizes. So I am now going to pass this off to Mark and Jerry, who's going to go into detail about what we're doing, why we pick these specific attributes in this challenge to address, how we're going to address it, and what more you need to do. So Mark and Jerry, I'm going to pass it to you. Thank you.
Thank you, Chris. This is Mark Hilberger, and my colleague Jerry will be jumping in as needed to go through these next slides. I'll just be giving you a brief overview of the challenge. But first want to start by talking about some of the technology gaps that we are trying to address with this phase 2 challenge. And as you can see in the list here, key technology gaps exist related to excavation of icy regolith and delivery of the acquired resources. And so phase 2 of the Break the Ice Lunar Challenge seeks to address several of the key technology gaps. Of course, excavation of large quantities of icy regolith, delivery of those acquired resources, but then also some cross-cutting technology gaps that we have with some of our other surface systems for construction and such, including hardware and equipment that's lightweight and energy efficient, hardware and equipment that's reliable and durable, and hardware and equipment that operates well in extreme and lunar environmental conditions, including reduced gravity and navigating complex terrain that includes rocks, craters, slopes, and loose granular soil. Next slide, please. So what we're asking in this challenge is that teams design, build, and test a terrestrial full-scale prototype icy regolith excavation and transportation system, and address the following design items. Prototype must be capable of excavating and delivering large quantities of icy regolith, capable of transferring materials from one machine or subsystem to another as needed during the excavation, transportation, and delivery operations, capable of operating in extreme lunar environments such as temperatures, lighting conditions, vacuum, low gravity, dust, and complex and rugged terrain. The systems need to be lightweight and energy efficient, and reliable and durable. Next slide, please. So the next two slides are a brief listing of some of the important requirements for this challenge. The full-scale robotic icy regolith excavation transportation system shall have mass less than 10,000 kilograms. It needs to fit inside a 6-meter diameter, 10-meter long cylindrical volume. And when we talk about a system, we mean a system that includes all the excavation equipment as well as the transportation equipment, and it can be the same robot. The system also includes any spare parts, tools, and equipment needed for repair and maintenance during long-term durability demonstration testing, and any tools and equipment needed to maintain the test area during the durability demonstration testing. And of course, more details are given in the actual rules document. Next slide, please. Additional requirements, and in this case, some restrictions. The excavation transportation equipment cannot use wired umbilical power. Only onboard power sources will be permitted. Cannot use wired communications. Communications need to be wireless. Cannot employ any physical processes, gases, fluids, or other consumables that would not work in a lunar environment. And some key examples would include air-filled or foam-filled tires, as they would not maintain their integrity, as well as ultrasonic sensors, for example, as they would not function in a vacuum. Pneumatic systems are allowed, but only if the gas is stored and supplied on board the robot itself. And similarly, hydraulic fluid systems are allowed only if the power and mass of heating system is included in the design that would be required to keep the fluid from freezing. So those are just some examples of certain restrictions. Electronic and mechanical components are not required to be space qualified. Next slide, please. So one of the key aspects or elements of this challenge is to conduct long-term durability testing. Of course, this is a very important technology need for us, as many of these systems we envision will be operating over very long periods of time in inhospitable conditions. So here are some of the key durability testing requirements that we have included in this challenge. We'd like to operate the prototype over a period of 15 full 24-hour-long Earth days. Perform a terrestrial location of each team's choosing under ambient conditions. And of course, some more details are given in the rules documents and what that means. Include both an excavation test component. There's also a transportation test component. The transportation test will haul the material that was excavated during the excavation test. Excavation test must extract simulated regolith as defined in the rules. Teams will be targeting excavating 12,000 kilograms of simulated regolith. Transportation tests must be performed in an area that complies with requirements provided in the rules. And there is some human intervention with the systems allowed during the long duration durability demonstration, but there are some limitations that are also provided in the rules. Next slide, please. So just one slide on icy regolith simulant requirements. It's a concrete type of material used to simulate the assumed mechanical properties of a 4% water weight lunar icy regolith. It's essentially a controlled low strength material with guidance provided in the American Concrete Institute report ACI 229R. This material will have to be verified to an unconfined compressive strength at the start of the excavation testing of between 1.5 and 2.0 megapascals. It's placed in one continuous pour. There is no need for dry regolith overburden to be simulated. And then there's some geometry requirements associated with the icy regolith simulant. Next slide, please.
Hey, Mark, I want to chime in on two points to reiterate and emphasize that you brought up. One, and it partially deals with this slide. So we want folks to recognize that there is a lot of uncertainty as to the form and the concentration of water ice in permanently shadowed craters. It could be extremely fluffy, could be extremely hard. And the mining technique that goes along with it can be a function of whatever we find. What this challenge does is looks at the worst case. If we have highly consolidated water ice in regolith, it has the strength of concrete. So we know how to excavate granular material. We have Razor and other programs going on associated with that. How we deal with a material this hard is what is part of what this competition is driving at. In the other chart, Mark mentioned, the duration. And in most other excavation competitions, typically they're, how much can you dig up in 15 minutes? When we talk about ISRU, and especially commercialization aspects, these things need to operate day in, day out, potentially for a good portion of each year when the sun is shining, or even continuously, depending on how you get power into the permanently shadowed craters. So to some extent, the other part of this competition kind of aims at the fact that life and how we operate are more important than how fast you can excavate something and deliver it over a short period of time. It's really, this is the marathon of operations, not the sprint. So I really wanted to reiterate those two aspects of why the competition was aimed towards these types of things. So Mark, you're doing a great job. Keep going.
And that's some great additional insight, Jerry. I appreciate you bringing that attention to the folks there. And feel free to chime in as you will. Okay, so let's see, we're on 27. Transportation demonstration. So we started with the excavation demonstration, then the second part of the demonstration is associated with transportation of the material excavated. And so one of the requirements would be a minimum one-way travel distance of 500 meters from the excavation site to the delivery site. And so this is a ballpark estimate of what we think a typical distance between these two locations might be on the lunar surface. And so that's where that distance came from. Transportation equipment shall then repeatedly drive on that same path throughout the durability demonstration test and drive this path in both directions equally. And this gets at some of the issues that we're expected to see associated with repeated trafficking and trafficability of a disturbed lunar surface, and some of the challenges that we're anticipating associated with that. Thirdly, the surface of the transportation demonstration should simulate surface conditions the team assumed in designing the icy regolith transportation system. Next, the design delivery location for the simulated regolith must be capable of not only receiving but also weighing the material that was hauled and delivered by the icy regolith transportation system. And teams are to target a delivery rate of around 800 kilograms every 24 hours. And this was something that I think we worked, or at least discussed quite a bit. The idea here was that a refining facility or processing facility will have a hopper only so big and will only be able to process material so quickly. And so having a continuous feed of material is what we're asking for here, as opposed to one giant delivery right away and then calling it a day. So that was the reason for actually defining a delivery rate. Next slide, please. Excuse me. We're looking for various types of data to be collected and recorded during the durability demonstration test. At least one live video stream accessible to the judging panel. Detailed photos of each major piece of hardware and equipment performing normal operations. Mass of each piece of equipment, including all the spare parts and repair and maintenance tools, whether used or not during the demonstration, and a total system mass. Also, measuring the energy used by each piece of equipment and total system energy during durability demonstration. Runtime for each piece of equipment. Total distance traveled by the transportation equipment. Total amount of icy regolith simulant excavated and delivered. Also, information on the compressive strength of the icy regolith simulant at the beginning and at the end of the 15-day test period. So essentially trying to verify that the icy regolith simulant that you were using in your demonstration is up to the requirement and that it remains at that number throughout the demonstration test. Also provide us with a list of parts that were replaced, any breakdowns that you had, any issues that required human intervention, along with the amount of time spent on repairing the excavation and transportation equipment. Also, finally, list any maintenance or repair of the transportation demonstration area. We realized that and spent a lot of time thinking about how to develop a demonstration area that could be achieved by a variety of different participants, and realizing that some folks will have to be doing their demonstrations outside. You might have rain, you might have some sort of weather condition that that degrades your demonstration area, and you will need to do some sort of repair. So we're acknowledging that and giving you opportunities to do sensible repairs. Next slide, please. So as was mentioned earlier, there's 3 levels to this competition. Level 1 is deliverables are shown here, and it's relatively straightforward. The deliverables of your title, team information, an abstract explanation of any intellectual property of the proposed system, a team video, any legal documentation, eligibility requirements, and such, a detailed design report of your prototype system, CAD models and or drawings, and finally the durability demonstration test plan. And this is the opportunity where the team is able to define exactly what their plans are for and justification for what their demonstration testing will be. Yeah, so evaluation, there's a evaluation criteria. Deliverables will be evaluated by the judging panel in order to determine compliance. Teams will receive just a standard go, no-go decision from this panel. The evaluation of deliverables and team compliance will take approximately 2 weeks from the time of submission. If a team is considered not compliant, they'll be notified of the areas that require additional attention. And you may resubmit the deliverables for further assessment and evaluation. There's no limit to the number of times that the team may resubmit. However, it does take, we're anticipating about 2 full weeks to do the evaluation. So at some point you will run out of time. Finally, teams that fail to submit deliverables will just be disqualified and not allowed to continue any further. Next slide, please. So level 2 is a very large part of this competition, obviously. We have the durability demonstration activity in here, and the deliverables will then include the actual test report based on that demonstration that details the results and what came out of the test, as well as a durability demonstration time-lapse video showing the team's prototypes excavating, transporting, and delivering the icy regolith. And final deliverable being a safety analysis where teams must identify any potentially hazardous material or other safety concerns associated with their system or demonstration test. Next slide, please. Level 2 evaluation, essentially 4 factors that are being evaluated with a maximum score of 100. First factor is mass efficiency, and the description is pretty self-evident. It's the total regolith simulant excavated per total landed mass. There will be a weighting factor that will be applied to the score that takes into account how closely the team's prototype excavation transportation system meets the target delivery rate of 800 kilograms every 24 hours. So it essentially does not allow a team to sort of loophole their way to the full delivery in the first day. They, again, as I was mentioning earlier, need to have a sort of a steady delivery rate throughout the demonstration test. Maximum score for this element is 40. Next is energy efficiency. So it's the total regolith simulant excavated per total energy used. And similarly, a weighting factor will be applied to the score that benefits the team who most closely targeted that 800 kilogram per 24-hour rate during the 15-day demonstration test. Maximum score for this element is 30. The third factor is related to reliability and durability. The extent to which the team's prototype robotic icy regolith system can handle the operational challenges of the long duration durability test. It will essentially be judged based on information provided by the teams in their durability demonstration report. Maximum score for that element is 15. And finally, lunar simulation fidelity. And this is the extent to which the team's demonstration area simulates the physical and environmental details of the anticipated lunar surface. And here again, we're leaving it up to the teams to develop and justify their simulated surface for their testing. We understand that people are going to have different available resources and locations, and so the hope here is that folks will be able to describe and justify the development of their surface and how well it simulates the lunar environment. And final max score there is 15 points for there as well. Next slide, please. Okay, so the final level, level 3, and as was mentioned earlier, up to 15 people or teams will be invited to this part of the competition. It'll take place over several days at a site chosen and prepared by NASA. And this part of the competition will include an excavation competition where teams will be required to excavate simulated regolith icy lunar regolith, be given a fixed amount of time to excavate as much material as possible. The excavation competition will also challenge the teams by introducing 1/6 gravity by implementing, we will be implementing some type of gravity offload system. And there's also a transportation element to the competition. It will take place on a course that we will have put together that consists of loose granular material. It will be constructed to include obstacles, including ramps of various slopes, cross slopes, and other obstacles such as rocks and boulders. And teams will have a fixed amount of time to navigate the course. No gravity offload will be used for that part of the competition. And finally, detailed testing requirements and judging criteria will be developed for this portion of the competition and will be made available at a later date. Next slide, please.
Yep, I can jump on in. Thank you, Mark and Jerry. So I just wanted to kind of close out this session by, again, reiterating the challenge registration and level 1 submission process. As we've said a few times, anyone can participate. But the way that the website is set up is essentially you need a user login before you can access the phase 2 registration form and the phase 2 level 1 submission form. So if you were a phase 1 participant, you already have a login and you can instantly access the phase 2 registration form. If you did not participate in phase 1, then of course you do not have a user account. So you'll need to create that first, and then you will be able to access your the phase 2 registration form and the phase 2 level 1 submission. We do have due dates associated with both the completion of the team registration form and the phase 2 level 1 submission. You can see those due dates right here. And with that, I will do a quick demo of the website. So I'm first just going to jump to our homepage. Can you guys confirm that you see my screen right now?
Yes.
Okay, perfect. So our site is breaktheicechallenge.com. Currently, you'll see that I'm logged in, and that gives me access to these two level 1 or phase 2 registration and level 1 submission forms. But before I go into that, I'll just to kind of orient you to some of the key websites on our challenge site. So the mission task is a very important page. It gives a granular deconstruction of what the phase 2 kind of mission task is trying to achieve. So it talks about the equipment design requirements, durability demonstration test requirements, the IC regolith simulant, all of the things that Mark and Jared just discussed. And so if you wanted to jump and kind of remember what the data collection process is, you could click on this, and then it would pull you down to the data collection components. And as they mentioned, all of this content on the website is pulled from the phase 2 rules document. So all of this is, essentially part of the phase 2 rules. But if you wanted to actually access the phase 2 rules document, you would first open this hamburger menu. This hamburger menu is how you navigate the website. And then you would pop over to the rules and eligibility tab, scroll down, and then you would be able to download a PDF of the phase 2 competition rules. And for reference, we also have the phase 1 competition rules. And then some of the key documents that are required when you first register is the eligibility requirements document. This is a document that you'll need to submit when you officially register. Then we kind of go over some of the eligibility as Chris was doing at the beginning of the webinar. So I encourage you to take a look through all of these documents. We have a how to enter page, which will walk you through the process of registering and then submitting. And also break out the specific level 1 deliverables that, again, we just went over: intellectual property, detailed design report, team introduction video, so on and so forth. And then it also speaks to level 2 as well. So I encourage you to look at the how to enter. The prizes page just summarizes the key prizes, which are broken down by levels. So you can see, you can pop through these different tabs to orient yourself to the amount of money that is on the table for folks who are able to deliver on this solution. We did roll out a forum feature. So those folks who are already logged in, you can create a forum. So we have had some, for example, this individual is a PhD student seeking to join a team. So if you are interested in, collaborating with other teammates or other collaborators, then I encourage you to take a look at this forum. You are able to post topics, and we approve them, and then basically you're able to, access a forum feature with other teams and other individuals who are participating in Break the Ice Challenge. The timeline, again, I encourage you just to orient yourself to what the overall key submission dates are. The most important ones are, of course, the phase 2 registration deadline and then the level 1 submission deadline. The FAQ page, this is a really important page. We have an extensive question, answer, response table here. So if you look, we have about 52 questions already answered. So, and then if you get to the bottom and you really haven't found your answers, feel free to drop in your name, email, and message, or you could just submit them to admin@breaktheicechallenge.com. So we're managing this website and actively updating questions. That said, a lot of questions we get have already been answered on this FAQ page. So I do encourage you to go through these this FAQ before you submit a question, just because we do get a lot of the same questions. And then finally, the resources and media page. This is kind of like our blog section, and this is where we will post our informational webinar. So this webinar will then be found on this resources and media page. Okay, I want to dive into the phase 2 registration form and just, again, speak to kind of the key forms that you need to complete. So with this challenge, we are all asking all teammates to complete the NASA Adult Media Release Form and the Team Bio Media Consent Form. So this is information that is used to socialize your team and allows NASA to promote your team. If you are the winner, we can, basically promote the name of your team. So that's important documentation. But another key document, as I mentioned, is the phase 2 eligibility requirements. So you will need to sign this document. And then part of that document is also an insurance acknowledgement, because to officially enter and compete in this challenge, you will need to have up to $250,000 worth of liability insurance. So that's an important distinction. For phase 1, it was, I think, $5,000. But given the kind of the fact that we're going to be building actual systems, tools, robots, and doing hardware, that threshold is increased. So that's an important thing to consider. But as I said, please begin by completing this phase 2 registration form. After you do that, we will reach out to you via the admin email, say, hey, great job, you are officially registered, and you can submit to the phase 2 submission form, level 1 submission form. Or if there's something missing, we might indicate what it is that's missing so we can make sure that you are in fact fully registered. Once you get that fully registered acknowledgement, you can open and access the phase 2 level 1 submission. And from here, again, you will see all of the same form fields that we've already mentioned. So you will have some text inputs for your abstract, your IP acknowledgement, and then you'll just be uploading PDF files for the team information, for the team introduction video, it's very important that this is like a YouTube or a Vimeo. If you're uncomfortable listing a public YouTube, you can list a private YouTube, but it is very important that the video link is accessible to our judges. In a past challenge for phase 1, somebody, for example, posted a Google Drive link and the judges weren't actually able to view that link. So just make sure that whatever link, it's easily accessible to anyone who can open it. And then when you upload your documents, so again, here's the detailed design report CAD model. These are the file types that we support for 3D CAD viewers. And you're able to save your progress as you go in case you want to just upload some of the documents. But we ask that you save the files using the following structure: team name, whatever your team name is, and then the submission element. So if I'm, you know, team break the ice, it would be team break the ice / CAD model. Okay, I think that's just about everything that I wanted to discuss. So I'll log out now. And again, just to show you, if you have not, the very first step, if you're completely new to the website, is to just create a user account. So all you'll have to do is create a username and password, and you can register right here. So with that, I think we can turn the call to the Q&A. So I will.
Hey, Ollie, can I say something about the website real quick?
Yeah, of course.
You mentioned that a lot of the website was copy and pasted from the rules, and that is true. There is a lot of rules content on the website, but the website is a summary of the rules document. The website alone does not give you all the rules, so it's very important to download and read and understand the legit rules document, and don't just presume that you've read every page on the website and you know all the rules. Thank you.
Yep, absolutely. So yes, this is very important to stress, and we'll just keep doing it, is download that phase 2 rules and requirements document. Just download it, print it, and read it thoroughly, because that is the ultimate document that guides this challenge. Okay, so give us a second as we start to process some of these questions. I'm going to either answer them live, or we will type an answer and I will pass them to one of our colleagues who has the expertise to answer them.
So Ollie, with only about 10 minutes remaining and about 18 questions, assuming we can't get to all the questions, do we want to encourage the teams to submit their questions to the website if we don't get to them in this meeting?
Yeah, exactly. So as we mentioned, we have an email box that manages this challenge. You can reach out with key questions if you are not seeing the answers already on the FAQ site. We might not be able to get to all of the questions today. So again, it's important that you're able to access answers after this webinar. Feel free to reach out with additional questions. So I'm just gonna hit some of the first ones. Will the recording be made available to us? Yes, the recording will be made available to you on the website on the resources and media page. This will be available within the next 3 to 4 days. We are a team from India and want to register for this challenge. In what category do we fall? Are we eligible for funding? You are eligible to register for the challenge, but if you do not have a primary place of business, you are ineligible for the actual prize award, but you are eligible for registering and competing in the challenge. Okay, we have another question. I could pass over to perhaps Jerry or Mark or Pete or Kurt. Will you provide specification for us to be able to recreate the properties of the lunar soil when we test our prototype?
Why don't I take a track? We specifically are not dictating the properties of the surface of your test track. We ask you to explain why it simulates the lunar surface that's consistent with your architecture. So some teams may have an architecture where they actually land a road building machine. It's part of the mass they have to weigh, and it goes and builds a road, and you drive on that. Other teams will land and expect to drive on existing as found material, and they would take their track and simulate that. When it comes to the actual properties of what you can expect on the moon, the lunar source book is an excellent place to go and find information about that. So that's, I guess, the start of the answer. Jerry, Kurt, Mark.
I would add there are lots of resources on the internet that teams can use. And I encourage teams to use the forum if they get stuck. And I want to reiterate that the forum is a way for teams to communicate with other teams. It is not a means for teams to communicate with the judging panel or the website, creators. But if you have, if you're needing help and other teams might be able to help you out, I encourage you to use the forum and ask questions there and share information and help each other out.
Great. The next question is, how much design iteration after the level 1 proposal submittal is okay? How much design iteration after the level 2 proposal submittal is okay? I guess this is a question really getting at if you start building your prototype and see that a kind of component of your detailed design plan is off or you need to update it, is that okay for you to update that existing kind of prototype?
For level 1, 2, once given, yet
You're kind of breaking up there, Pete.
sorry. So once you've been told you have a compliant proposal, you can modify your design. As a matter of fact, if you look at the submittal for level 2, part of the design report is to report any changes in the design from level 1 to level 2. Level 2 is actually run the robot, so there is no design iteration after level 2.
Yeah, so both the schedule, to summarize, both the schedule and the deliverables basically drive how much design iteration is allowed.
Great. Next question is, can we add team members after we register? Yes, you are able to add team members. Your team members are listed in the eligibility requirements document. So if you do add team members, all that we'd ask is that you update, and you could just send that to our Break the Ice admin email and just indicate the update, and then we will basically update your eligibility requirements document with all of the present team members. But as long as you as a team lead register your team, then you can, you're not fixed at that level. You're able to add more team members. Can the teams participate with some international individuals? Again, yes, international participation is encouraged and welcome. The key distinction with international participation is that given the requirements of this challenge and the legal framework, prize money is unable to be distributed internationally. You must be have a place of residence or primary place of business in the United States to receive prize money, but you can participate with international individuals. All right, the next question is, the maximum depth of the icy Regulus simulant is specified to be 80 centimeters. Is there a minimum depth?
No minimum depth. Fine.
Sorry, Pete, again, you were kind of cutting out. You said there was no minimum depth.
No minimum depth defined in the rules.
Great, thank you. Okay, the next question, can other infrastructure that is designed to facilitate dumping the regolith be manually set up at the deposit site?
I would say the answer to that is any infrastructure you put in place, you have to weigh it and it counts against your mass. And if it uses any energy, you have to calculate that energy and that counts towards the energy utilization.
Yeah, it's part of your system, in other words. Your system can be, and we've mentioned this several times, your system can be one robot, it can be several robots, it can be a lot of robots. And so, you know, everything that you add to your system that aids in the process, that's part of your system. It has to be weighed, energy taken into account, and all and the volume taken into account. As Pete said, yep, it all counts.
Okay, great. And then we have kind of two questions of similar nature. Can we stop the timer overnight or for any other reason? And then a similar question to that, is bad weather, rain occurs during the test, can testing be paused? Can the test track be refurbished afterwards? So first, can we stop the timer overnight or for any other reason? And then next, if there's bad weather during the test, can testing be paused and then the test track be refurbished?
So the timer starts and runs for 15, 24-hour days. If you want to stop running your robot at night, that's fine. You don't get an additional 8 hours at the end of 15 days. So it's start and it's a continuous 24-hour clock for 15 days.
Right. So the duty cycle of your system can be whatever you decide, but if your duty cycle has a lot of downtime, then that's a disadvantage. So we're trying to encourage teams to run their robots, you know, almost continuously, in order to put them through their paces and see what they can do, and see if they can handle this operation, this long duration. We've called this a long duration test all throughout the rules. See if these robots can operate long duration without breaking down. So that's really, you know, one aspect, one part of this challenge. If a team decides to shut down for some reason, then that's going to be a disadvantage. They will, you know, their efficiency will go down for that downtime, but the timer doesn't stop. That's the whole point of this long duration test. Hope that makes sense. Hopefully it's clear in the rules.
Yeah, and then similarly, a kind of similar question to that is during level 2, can we perform the long duration test multiple times and then submit the best result?
The issue with multiple times. So if you want to shake out your equipment, shake out your test track, do some trial runs, you can do as many as you want. But in the rules, we ask you to submit a date you're going to start testing, and you have to have a live video stream, and you can expect an observation visit from one of the judging panels. So you can only do that for one test. We're not going to send out a judge multiple times because you say, well, that test didn't count. So feel free to trial run your equipment. You can make as many runs as you want, but when you're ready to be judged, you have to inform us, this is the one I want judged. Stream it live, let us know when it starts so we can come to visit.
Wonderful. And with that, we are at the hour. So just to kind of go over some of the next steps, please complete and submit the required paperwork and the forms by September 30th, 2022. Please stay connected with us. Please use the Break the Ice Challenge website. You know, of course, the NASA Centennial Challenges program is on Twitter, Instagram, Facebook. And then do not hesitate to email admin@breaktheicechallenge.com. We are processing, many responses. So sometimes it might take us 1 to 2 days to respond, but we are actively managing that mailbox. Well, great. I want to thank everyone for your valuable time, for contributing to this important challenge. And with that, I will close the webinar. Good luck, everyone.